What's going on, YouTube? Myself, Divesh Jadwani. I welcome you all to this brand new playlist where we will be learning AI agents with the help of a beginner-friendly project, which I would like to call as Agentic YOLO. This project is gonna be really, really interesting as we speak of, and I can't wait to show you how it looks like and what are we trying to achieve. So yeah, let's just dive into the screen. Let me share my screen and see how that is gonna work out. So here we are onto our project introduction, which is called Agentic YOLO, like it looks. Now, Agentic YOLO is a combination of two things. One is AI agents and another is YOLO algorithm. YOLO is a pre-trained algorithm for the introduction basis, which has the full form of you only look once. Now, what we are trying to achieve is we are trying to combine the AI agent capabilities with the superpower of YOLO. Okay, it might sound tricky in the initial stages, but let's break it down one by one. In the AI agents part, we will be covering Autogen to initialize and make AI agents. And YOLO will be the kind of superpower we will be giving to our AI agents, like we spoke of. Yeah. So let's quickly start to understand what the problem is, and then we'll just start to address that problem. Yeah, let's go. So let me show you this image. In this image, when I give a prompt, like, let's just first count the number of people in this image, like 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, and 15. Yeah, we can see 15 people in the image. And when I ask this GPT or any LLM to count the number of people and detect their locations specifically, let's see the response. Yeah, so we can see close to accurate response, and we can also see the locations: person in blue, person in maroon, person in woman, etc., etc., etc. This is not the kind of output we are looking for. The kind of output we are looking for is something like this. Yeah, something like this, where it should detect the people or anything which we are trying to achieve. Yeah. Now, YOLO is a very good algorithm as we speak of. It is used to achieve a lot of tasks. For example, classification, that is this a person, is it a safety vest, etc. It is used to, segment the objects from the image. It is used to track the objects from the image. And it is also used to detect pose detection. These kind of things YOLO is famous for, and YOLO is made specifically for this thing. Okay, let's talk about another example. Let's say I have this data set, thyroid cancer data set, where we have two type of classes, cancerous and non-cancerous. I just pick a random image from any one of these. Yeah, just a random image I am gonna take. And when I give this to GPT or Gemini, let's say Gemini, okay, and I just simply ask it to classify that if this is cancerous or non-cancerous, okay, this is the kind of reply we are getting, that I'm unable to provide a classification for the medical image that you have uploaded. Okay, as a language model, I'm not trained to interpret medical images, which is but obvious. We cannot give them the entire, we cannot be relying on these large language models for medical images. But what if we want to be relying on these images? Yeah, that's exactly where our project is coming in between, Agentic YOLO. Let's look at how YOLO is performing on medical images. Let me open this image. Like we can see this image. In this image, we can see these are the results of YOLO algorithm and how accurately YOLO has spotted cancer in all these brain MRI images. Okay. So now we are trying to understand the superpower of YOLO, which we will be giving to AI agents because they don't have the superpower right now. Okay, we'll not be exactly making this kind of output will not be exactly achieving a medical kind of output because it gets a little complicated and not so beginner friendly. But we'll be achieving something which I'll show you immediately. Let me show you that. Okay. Yes. So let me show you this output. So I'm just gonna upload a image to my AI agent. I'm using Gemini model internally, the one which said that I cannot interpret medical images. Now I'm giving the same image, this image. I'm gonna give this image to my Gemini model, and I'm gonna ask it to, you know, count the exact number of people and detections. Okay, the same thing which I said. I'm just gonna pass it here on my in my code. Let us see. So can you describe anything about the image and also the exact number of people at the path? We have to provide the path for several reasons. We'll talk about that. Let us see the output. See, this is the kind of output we are looking forward to, of course, because we have given the superpower. And this is the output. The image contains a group of people likely at a ceremony of event. Yeah, cool. Extra information is always better. There are at least 15 people present. Yeah, which is very much accurate because, you know, it has used its superpower, and the confidence scores are quite high, ranging from high confidence over zero point 0.8 to low confidence 0.5. And yeah, so this is Agentic YOLO, where we are giving our AI agent, which means Gemini, the superpower of YOLO to perform the task which it does not usually. Yeah, it can. Okay, we call them large image models. They have the capability to do that, but in the end, it's not accurate. There is some terminology we have this in AI agent book space, which is called as hallucinate. Okay, so these AI models hallucinate a lot while giving results, and we wanna reduce that. And in order to rely on AI agents in terms of medical areas, to be very precise, we can target some project like this, Agentic YOLO. Again, we are not trying to make a medical use case in this project because it slightly goes out of the context of beginner friendly, but I'll definitely tell you how we will be going with respect to how you will be going with respect to this Agentic YOLO. Yeah, thank you so much. I'm really excited to see you in the project, and I can't wait to tell you how this is made.